In the previous episodes, Emily and Mauricio have worked hard to reflect on Alexa's equation. In this episode, they will continue to think about the mathematical meaning of her equation by thinking about the distributive property. Previously, they have thought about the meaning of distributivity in a different context, of vegetable gardens. But in this episode, they will think about where they see the distributive property in Alexa's equation, and in the context of Noah's rectangle of fabric.
Do you remember when we were working with gardens that we were just changing one dimension, like the length?
Mm-hmm.
You were using distributing. Do you see anything that looks like it could be distributed here?
Like, why? Bottom half. Why? Time. Or no, but
Do you guys remember an example of when you distributed on a previous task?
yeah, like we did like this length, or like I feel like
Do you remember distributing? Let me see if I can find one real quick. Does that look familiar?
yeah, like
Where
Four.
did you distribute?
4 times 5 and then 4 times 6, which it was a 4.
Oh, it was like the width times
The
the
length.
length.
Oh, I think we could do it.
Let's take a look.
Emily and Mauricio remembered their work from a previous lesson. They had used the distributive property in the context of Jamal's vegetable garden. They used parentheses to express the area as the width, 4 feet, times the length, 5 feet plus 6 feet. When they distributed, they, as Emily put it, multiplied the width times both of the lengths. They distributed the width of 4 feet to the length of 5 feet and to the length of 6 feet to get an equivalent expression of 20 plus 24. Next, they will think about how the distributive property applies to their situation.
Y times Y times 4.
Yeah, like that. Like. Add?
I don't remember that.
Yeah, it's adding that, which would give us
What would you get if you
Wait.
distributed that?
why? No, that would not even give the area. Oh, it could give you these two areas.
Ah,
It could give these two areas.
how do you see that, Mauricio?
Because y times y, and which will give us this area. And then y times 4, which will give us this area.
What do you think of that, Emily? Not sure.
No, I think it'd work like that.
And tell me where you see, like, just go back to that statement at y times the quantity. Yeah, before you distribute, where is the y that you're seeing on the picture?
Right here.
Okay, and you're multiplying it by what?
The y right here
Oh,
and the y right here.
yeah, so does it make sense that it would give you those two areas, the pink and the blue?
Yeah.
Okay, and then what did it look like when you distributed?
Can
you go ahead and do the distributed?
Like that.
Yep.
So like that, and that'll give this part the one in pink, and the y times 4 will give us the blue spot.
Okay, below that could you write what you get when you distribute? So when you multiply y times y, can you write that?
But I don't know what it gives.
Well, let's try it. So I'm right here. Can you put like right below this equation that you wrote?
Yeah.
What is y times y?
Y inches squared.
Can you write that down?
Then
Okay, is that correct? Is that the area of the pink part?
y squared inches squared.
Okay.
Then plus the 4.
Now, what do you think of that? Can you find those in the drawing?
Mm-hmm.
Where do you see them, Emily? And what does that mean? Is that
The areas.
the two areas? Okay.
Yeah.
What do you guys think? Could you use distribution again and get the areas you're missing? Because you're missing a blue and yellow.
I think you could do that.
Okay.
Yeah.
Try.
You want to do it?
No.
By the same thing, we could do it by the same thing. Y plus 4.
And where do you get the? How do you see those in your drawing?
The 3 times y is gonna be right here.
Okay.
So 1 plus, and then this is the 4 too, distributing 2. And that's gonna the 12 inches squared.
Okay. What do you think of that? What did you discover?
Wait, we gotta plus that too. Because
Ah,
this whole equation is gonna equal
what does it equal?
Noah's rectangle. Noah's area.
And can you find what you just underlined up in the first equation? Do you see it?
What you mean?
The thing you just underlined?
Yeah, this equation?
Is that in? Can you see it in Alexa's equation also?
Yeah.
Where is it?
This plus this plus this plus that.
So that's pretty interesting what you figured out, that you're using you're distributing twice.
Yeah.
Emily and Mauricio discovered something really important. They discovered that distributing twice gave them each of the 4 areas comprising Noah's rectangle of fabric. The first distribution was similar to what they had done with the garden. They wrote y times the quantity y plus 4, which represented the width of y inches multiplied by the length of y plus 4 inches. But distributing the y only gave them 2 areas. The first was y times y, or y squared inches squared. And the second was y times 4, or 4 times y, inches squared. To find the missing areas, they had to distribute again. They wrote 3 times the quantity y plus 4, which represented the width of 3 inches multiplied by the length of y plus 4 inches. Distributing the 3 to the y and the 3 to the 4 gave them the missing areas of 3 times y inches squared and 12 inches squared. When combined, both expressions represent the area of Noah's rectangle. Lastly, Emily and Mauricio made a smart connection to Alexa's equation. Indeed, first they distributed the y to the y to get y squared. Then they distributed the y to the 4 inches to get 4 times y. To find the missing areas, they distributed 3 to the y to get y times 3, and the 3 to the 4 to get 12. So distributing twice represents several multiplications of length times width, which results in each of the parts of the area of Noah's rectangle, represented in Alexa's equation.